Hi there, this is Ozer from Team Nile. Welcome to the second episode of our closed-loop automation demo series. In the first episode, my colleague Shiv demonstrated how the Nile Access Service enables deterministic design and installation for wired and wireless connectivity across campus and branch locations. In this demo, my colleague Dipen will discuss how we automatically tackle wireless coverage issues due to physical layout changes within an indoor space without any manual intervention. We call this the continuous survey. But before he does, let's quickly review the innovation principles behind the Nile Access Service. To start with, instead of just shipping you a bunch of boxes with equipment inside and wishing you good luck, we provide industry's first guaranteed performance in coverage, capacity, and availability. This is possible thanks to our closed-loop automation capabilities powered by AI. With an integrated data model across all components of the Nile Access Service, we translate the network and environmental context into a digital twin. This allows us to automate tasks in the digital world and validate outcomes before taking action in the physical world. Embracing an as-a-service mindset, we enable radically faster deployment and hands-off maintenance of wired and wireless networks at the enterprise edge. Nile Access Service additionally offers budget flexibility with monthly or annual consumption options without any upfront capital expenditure required. In the first episode of our demo series, we saw how the design and installation of a wired and wireless network can be made significantly more efficient and deterministic with closed-loop automation. However, after the initial installation, many tasks for network operations still require many steps and manual effort. These include software updates, wired and wireless network troubleshooting, IT support ticket management, ongoing network element configuration, and managing network capacity and coverage. With the Nile Access Service, we want to eliminate the inefficiencies within these day two operations as well. Now let me hand it over to Dipen as he explains what happens when there's a wireless coverage issue due to an external factor within a Nile network.
Thanks, Ozer. Welcome to this episode. My name is Dipen Varde, and I lead the wireless service here at Nile. Now, as a service, we had to rethink several areas that make up the access networks, especially when building a service backed by guarantees. And one such key area is optimized RF channel planning. While RF channel planning algorithms have evolved and become smarter, in parts, it's still in a silo. It lacks the benefit of deterministic closed-loop installation, site-specific data from the survey, to build a strong foundation for channel planning to run on top of it. And it often lacks the outside-in view from the end device perspective, in addition to just the AP to AP visibility. At Nile, we are able to ensure the foundation of the wireless network is built correctly, using closed-loop installation to weed out any deviations at the time of install. The site-specific survey data, such as power levels used in the active and predictive survey to ensure coverage, are fed into the channel planner, along with data such as height of AP. Once the digital twin for not just the Nile elements, but a twin for the entire environment is set up, it is constantly being hydrated by deep instrumented telemetry from APs as well as the sensors. If the layout of the physical environment changes, that alters the RF coverage. With the data, we are able to run a decision tree and detect changes in the RF environment. The digital twin is updated with the power changes required to ensure the coverage is restored, and in parallel, automatically initiate a work order for our customer success team to possibly set up a site survey again and inform the customer. That's the kind of closed loop continuous survey we are talking about. It's not just about mitigating coverage problems based on the AP to AP visibility. It is about closing the loop to ensure that the RF environment changes are addressed by possibly setting up a follow-up site survey. Detecting widespread environmental and geographical changes is achievable when the end device perspective from Nile sensors is incorporated into the channel planning. And and closing the loop by follow-up survey if required. That said, what customers are getting through our service is not just channel planning, but a continuous RF site survey that's detecting environmental changes. That said, let's jump into a real world example of how this plays out. You're looking at, for the very first time, the Nile Autopilot. Internally, we also call this the Nile Operator Portal. Let's look at some of the constructs that I alluded to earlier. Firstly, the digital twin. The entire Nile service block, including the APs and sensors, has a digital twin for the exact topology for that customer in the Nile's Autopilot, or the Nile Operator Portal. There is a lot of rich information available out here. We also alluded to the telemetry that's constantly hydrating the digital twin. If you look at the amount of data we collect, including the device's state and health, device logs, device events, and not just that, we're also looking at a bunch of telemetry data for several different topics that we collect. Just to give an example, what does the air quality look like? And this includes things like the channel load, non-Wi-Fi utilization, Wi-Fi utilization, what are the BSSIDs seen in the vicinity, what does the channel health look like, client health, and so on and so forth, all the way down to the device hardware related telemetry, even the transceiver, LLDP related metrics, OSPF related metrics, the CPUs, memory, you name it. That said, let's go back to what this incident was about. As you can see, this incident was about a coverage SLA violation. So this particular customer on this particular floor, the sensors seem to be reporting low RSSI neighbors. This is the outside in view that I was alluding to earlier. Not only that, as you can see, this ticket was automatically analyzed by the software, and it detected that the cause is most likely the Wi-Fi environment. Let's look at the things it checked for. It says that the known RF neighbors found previously are still active. That tells me basically the APs have not rebooted. None of the APs are down. None of the sensors are down. Just that the perceived RSSI of the APs from the sensors perspective has changed. And that basically means there has been a Wi-Fi environmental change. This is the rich telemetry that's constantly hydrating the digital twin, not just the elements, the APs, but the digital twin for the entire environment. This includes the noise floor, the channel load, and the channel load is further broken down into what's my RX-TX utilization, as well as non-Wi-Fi interference, interference due to external BSSIDs, and so on and so forth. Again, things that normally you would collect for channel planning purposes. However, in this case, it's not just the AP to AP. We are also collecting data from what are my sensors telling me about the Wi-Fi environment from the end device's perspective.
Hey, Dipen, impressive demonstration. Thanks for walking us through those steps. And thank you for tuning in. As you can tell, we are radically reducing the amount of time it takes to detect and resolve wireless coverage issues that might happen due to external factors. Hope you found it relevant to your environment. We are looking forward to continuing the conversation at nilesecure.com. In the meantime, be sure to check out the other episodes in our demo series, highlighting how the Nile Access Service utilizes closed-loop automation powered by AI to tackle wired link issues, software bug fixes, and system software upgrades.